Okay, so today we're going to look at combining inequalities together. So questions typically look like this. Find the region for which both the following inequalities are true, and they give you two separate inequalities. And it starts off quite simply because to begin with, you just have to solve both inequalities separately. So dealing with that, take away the 4 from both sides, you get minus x is greater than minus 2. Now remember, when you're multiplying through by that negative number, what do you have to do? You have to switch the inequality the other way round. So we end up with x is less than 2. Okay, now you could have added x to both sides, but doesn't matter. Now with this one, I'm going to add the x to both sides, so I get 2x on this side, and I'm going to do the take away 4 at the same time. So I end up with 2x is greater or equal to 1, so x is greater or equal to half. So we want to find the region, in other words, the values of x for which both of these inequalities are true. And I found that the best way to do this is go back to thinking about inequalities on our number line. And if I draw my number line and I draw the first inequality, which is x is less than 2, if I put my number 2 on the number line, remember x is less than is an open circle because that's what less than is. Or closed is filled in circle for less than or equal to. And if x has got to be less than 2, then it can be any number to the left of that circle. So we draw a line with an arrow to indicate that it's any number to the left. So that's my x is less than 2. I'll draw my other one in a different colour. So this time I'm going to have x is greater than equal to a half. So I need to put my half on the number line. It's going to be greater than or equal to. So this time it's a solid circle. And because it's got to be bigger than a half, my arrow goes the other way, goes to the right, because it can be any number bigger than a half. So I've got my x is greater or equal to a half. Now, I want to find the region when both of these inequalities are satisfied. In other words, when both these inequalities are true. So if I get the highlighter, that's basically the region where we have both inequalities. And so if I draw that underneath, that is going to be going from a half with a solid circle all the way up to the number 2 with an empty circle. That's the region where both of these inequalities are true. And the way I would write that is, so my x is going between a half and 2. So I'll write a half is less than or equal to x, because it's a solid circle, is less than 2, because it's the empty circle. And that's the region when both inequalities are true. So I'll do a second linear one. So again, first step is we solve the two inequalities. So I'm going to add x, and I'm going to add the 2 at the same time. So I get 3x is greater than 9. So x is greater than 3. The second inequality, I'm going to multiply by 9. Now, because x minus 2 is all over 9, that just becomes x minus 2 is greater than 9, because I'm timesing 1 by 9. So x is greater than, add the 2, 11. Right, let's do the number line now. So for the first inequality, I've got x has got to be greater than 3. So it starts at 3 with an empty circle and goes to the right. The second inequality says that x has got to be greater than 11. So it starts at an 11 with an open circle and goes to the right. So where's the region where it's true for both? Well, it's just the same as the second inequality, x is greater than 11. So that is the region when both inequalities are true, or when both inequalities are satisfied. Right, guess what? We can have a linear and a quadratic inequality. We could have two quadratics, but you don't tend to see that. I always tend to do the linear equation first just because it's easier. So multiply through by 2, 3x plus 10 is less than or equal to, 4, because remember we've got to multiply every term by 2. Take away the 10 from both sides. So 3x is less than or equal to minus 6, because 4 take away 10 is minus 6. So x is less than or equal to minus 2. Going to the second inequality, I'll change the colour here actually. Remember, to solve quadratic inequalities, we have to sketch. So we actually have to sketch 4 minus 3x minus x squared first. Now, note, it is a negative quadratic. Okay, so it's going to be an N shape rather than a U shape. So that's the first thing to know. What type of quadratic is it? It's a negative. What do we need? We need where it crosses the x-axis. So we need to solve 0 equals, because on the x-axis y equals 0, 4 minus 3x minus x squared. Now I could try and factorise that, but factorising negative quadratics is more difficult than factorising positive quadratics, so I just automatically multiply through by minus 1. And I write it in the more normal way with the x squared first. So minus x squared is going to become plus x squared. Minus 3x is going to become plus 3x. And 4 is going to become minus 4, because basically you're changing the sign of each term. Nice and easy to factorise, because you've got 4 times 1. And you've got to have the plus 4 and the minus 1. So either x plus 4 equals 0, so x is minus 4, or the x minus 1 bracket equals 0, so x equals 1. So when we come to sketch it, we end up with crossing at minus 4 and 1. Remember, it's that negative quadratic, so it's an upside down one, so it's going to look like this. Now we want the region when y is greater than 0, because again, looking back here, my equation is greater than 0, so y is greater than 0. So that's this region above the x-axis. So my inequality becomes, my x has to be between minus 4 and 1. The way we write that is minus 4 is less than x is less than 1. Okay, so now we draw our number line so that we can put these two inequalities together. So I'm going to draw it quite low. So my linear inequality says x has got to be less than or equal to minus 2. So I'm going to put minus 2 there. So my x has got to be less than or equal to, so it becomes a solid circle. And it goes to the left because it's got to be smaller than minus 2. My quadratic says x has got to be between minus 4 and 1. But again, these are empty circles because they're only less thans. So, where is my region where both are true? Well, that is just this region here. And so the region where they are both true is between minus 4 and minus 2. And so I write that, so they are both true when x is bigger than minus 4 but less than minus 2 at the same time. Okay, right, second example with the quadratics. Just got 3 examples for you today. So again, do the linear one first. So add the x to both sides, take away the 1 from both sides, and you get 4x is greater than 2, so x is greater than 2 over 4, which is a half. Right, so the quadratic, what have we got to do? We've got to sketch y equals 4 minus x squared. To sketch it, we need to work out where it crosses the x-axis. So on the x-axis, y equals 0, so 4 minus x squared equals 0. 4 is equal to x squared, so x is the square root of 4, which is plus or minus 2. So that's where it crosses the x-axis, minus 2 and plus 2. But again, what have we got? We've got a negative quadratic, so that means it's an N shape. So we've got our N shape, and we want to know, getting the highlighter out, when my curve is less than 0. So we want to know when y is less than 0. So that's these parts here when it's underneath the x-axis. So y is less than 0 when x is less than -2 or x is greater than 2. Remember, when it's two separate bits, you have to write them as two separate inequalities. So let's get our number line on the go to combine the two together. So my linear inequality says x has got to be greater than a half. So there it is. It starts at a half with an open circle and it goes to the left. My quadratic inequality says x has got to be less than -2, so I'll put a circle at -2 and go to the left, or it's got to be greater than 2. So it starts at 2 and goes to the right. So where are both these inequalities true at the same time? Get the highlighter. Well, they're only both true from that point, from 2 onwards, from 2 bigger. Anywhere else on that number line, if you think of any other position, if you think about here, only one of them is true. Here, neither of them, none of them are true. Down here, only one of them is true. So there's only one place where they're both true, and that is when x is greater than 2. So both are true when x is greater than 2. And the final example. Okay, so again, split the page because I'm going to do them both separately. I'll do the linear one first, just out of habit, because I always do the easier one first. So I'm going to multiply through by 2. 3x plus 16 is greater than 4. Take away the 16. 3x is greater than -12. So x is greater than -4 for the linear inequality. The quadratic inequality, I've got to have a 0 there. So first thing I've got to do is actually take away the 4 from both sides to get x squared minus 3x minus 4 is greater than 0. What do I have to do to solve a quadratic inequality? I have to sketch y equals x squared minus 3x minus 4. Now realise, okay, this one now is a positive quadratic. Okay, so this is your nice U shape. So how do I sketch it? I need to find where it crosses the x-axis, and on the x-axis y equals 0, so I'll get 0 equals x squared minus 3x minus 4, and again quite a simple one to factorise. So I've got a 4 and a 1 and I want a -4 and a +1. So either x plus 1 equals 0, the first bracket equals 0, so that must mean x is -1. Or the second bracket is 0, so x must be 4. So sketching that, got my -1, my +4, and it's a U-shaped quadratic. Looking back to the equation, the original inequality that I'm trying to solve, I want the curve to be greater than 0. So that means I want my y to be greater than 0. So that comes back to the bits on the ends, because I want it to be above the axes. So what does my inequality become? It becomes x is less than -1 or x is greater than 4. Okay. Right, final step, put the two inequalities together. So first one, x is greater than -4 for the linear one. So got my -4, and so for my linear equation it says x has got to be greater than -4. If you look here, x has got to be greater than -4. Now if I put my quadratic result on, it says x has got to be less than -1, so it starts at -1 and goes to the left, or it's got to be greater than 4. So now I've got to find all the regions where both of these inequalities are true at the same time. And actually there's a couple of different parts here, because you can see they're both true in this region here between -4 and -1, but they're also both true when you get larger than 4. So I actually, again, just like I did with these inequalities for the quadratics, when they're separated, you have to write them as two separate inequalities. Well, the true is down here. When they're separate like this, again, I have to write them as two separate inequalities. So for the part over on the left-hand side, my x can be between -4 and -1. So I write -4 is less than x is less than -1. Or, and then I go to the other part of the inequality, x can be greater than 4. So both inequalities are true when x is either between -4 and -1, or when it's bigger than 4. Okay, right. 4 for you to have a go at. Press pause and then I will show you the answers. Okay, first one, hopefully you did the linear inequality straightforward. Second one, make the inequality 0 first and then write that you're going to draw the sketch. In this situation, we wanted our quadratic to be less than or equal to 0, so we wanted our y to be less than or equal to 0, so we were underneath the curve. So the two inequalities that we ended up with was x is greater than 3, so I ended up with this region here, x is from 3 to the right, or x is between 4 and 10, so we had between 4 and 10, and the region where they're both true actually is only when x is between 4 and 10. So the answer to the quadratic inequality actually is the same as the answer to the whole thing when they're both true. Okay, so again, linear inequality, hopefully you could follow that. The quadratic, slightly more complicated to factorise, but again, we want to draw the inequalities when the y is less than 0. So we want the y to be less than 0, so we want underneath the curve. So we've got our two inequalities. X is less than 2/3, which is the one in the red on the number line, or x is between -1/2 and 3. And the region when they're both true is just here. So it's just between -1/2 and 2/3. So for both to be true, you should have had -1/2 is less than x is less than 2/3. Right, let's have a look at number 3. Linear, straightforward. The quadratic, I took the 12x and the 4x to the other side just to keep it a positive x squared. So I wrote it as 0 is greater than x squared minus 4x minus 12. So I did the sketch of x squared minus 4x minus 12. Now, don't get mixed up here. 0 is greater than the y. So 0 is greater than the y. But that is the same as saying y is less than 0. So it was underneath the axes. So the region was between -2 and 6, which we write as -2 is less than x is less than 6. Put the two inequalities on a number line, and the region when they're both true is between 1 and 6. So we write that as 1 is less than x is less than 6. And the final one, again, the linear, fairly straightforward. You just got x is greater than -2. Quadratic, no, it's a negative quadratic, so it's going to be that N shape this time. But we solve it by finding where it crosses the x-axis. And where it crosses the x-axis is when y is 0. So I multiply through by -1, factorise, and you end up with it crosses the x-axis at 1 and at -3/2. Remember, it's that N-shaped curve, and looking back at the inequality, we want our y to be less than 0. So we want it to be underneath the x-axis. So we've got the two separate parts this time, so we write it as two separate parts. And drawing them both on the number line, this was one where we had, sorry I haven't finished that one off. Oops. We had our two separate bits. So we had the part between -2 and -3/2, but we also had the part when x is greater than 1. Okay, so that's the final for both inequalities. Both inequalities are true when -2 is less than x is less than -3/2, or x is greater than 1. Okay, quite a lot to digest today, so you might need to watch the video another time and watch the examples again, but hopefully you can have a go at the worksheet on Edmodo.